Hi guys, this is the tutorial workthrough for the third lab we did on fur data level. And I want to get us to a point where we can plot our data and make it look something nice like this. So we're going to get to that stage because with this data set, the analysis wasn't so difficult. So we want to focus a little bit on plotting stages, but we also want to focus a little bit more on data manipulation in the R environment too. Okay, so I've gone through, we've collected all our fur data. It's been put online, but I've also now added in the data from Fraser Coast, which I've been sent. So I'm going to upload this um, as well as this code, so you'll be able to access both. So the new data is looking good, and if I want to bring it up, I just have to point it in the right direction. I have to set the working directory. I can do that in code, or alternatively, I can go session set working directory. That way, I'm going to use code. So I've set it to F drive, which is my USB stick, and I want to read in our data. So that's our data. You can see we have 5 variables: fur, which is what animal it was, fur length, skin thickness, fur density, and that slope, which was the cooling coefficient. And we have 53 observations, so that's looking good. Now, the first problem we had with this data was that it's labeled a little bit differently depending on who was writing in the data. You can see we have cases here where it's called calf versus cow, and other cases where we've got fox with a lowercase f or fox with an uppercase f. So we have to fix that because we want all these to be the same, otherwise they're going to come out as different colored points in our plot. So there's multiple ways that we can do this. We could, of course, like just change to CSV in Excel, which is not very fun. Um, One of the ways I'm going to show you is quite simple. Here we're just going to find a particular case, and we're going to find this case using this which function. And in this case, I want to find which of these my data fur. So if I just run that my data fur, you can see here's my data fur. And I'm asking it which ones of these is this fox with the lowercase f. So you can see this is 25, but it actually starts here at 23, 24, 25, 26, 27, 28. 20. So I want to be able to do that automatically. So I'm going to use this which command to find me the rows where this fox is lowercase, and I'm going to put them into a variable called ind. So let's see. So now you can see I have this variable called ind. It starts with 23 and it's identified all the cases where that fox has got the lowercase f. And now I'm just going to change them. So find all those cases and change it to be uppercase f. So once I've done that, I can rerun that. And now you can see all those lowercase f's are being converted to uppercase f's. I'm going to do the same with kangaroo because you notice kangaroo's lowercase here. I want to make it all uppercase. The other one is we've got some with calf and some with cow. So I'm going to find all the cows and replace them with calves. And so hopefully now if we run this, it looks good. But the problem is you can see these levels at the bottom here. We still have these leftover levels, even though there's no cases with those levels. That can be a problem with plotting in the future. So we want to drop those levels. And I'm going to use this drop equals true. And hopefully that should now update my levels. And it has. So they're all very much the same. And these are all the levels that we have. So now everything's looking good and we can get back to looking at our data. So the first thing I'm going to do is plot fur length against the slope. Here's what our data looks like. Remember, we can pick any color we want here, and our data is going to look quite nice. If we want to have a look at the fit of that data, we can use this linear model function, this LM function, on our data, and I'm going to put that out to a variable called fit, which is what you see here. And then I'm going to call another function called summary, which is going to summarize this fit. So what I've done here is 2 steps in one. I could have run this step first and then had a second line where I just went summary fit, and it would have resulted in the same output if I run these 2 lines versus this one line here. This is just combining these two lines together. So don't be too confused by this complicated line. So if I run that line, I get this output. If I run this line, the first thing, it just creates this fit, and then it creates a summary of that fit. Okay, so when we're reading these summaries, we're interested in a few things. We might be interested in the slope of the line, we might be interested in the intercept. But in this case, we're really focusing on the R squared, the F statistic, and the p-value. In this case, our p-value is less than 0.05, so it's quite significant. If you look at the R squared, it is quite high. It's about 0.51, say, which means we're explaining about 51% of the variance, significantly explaining 51% of the variance in this data using fur length. And that's why we get such a big F statistic here. Now, what we want to do is compare our three different measures of fur and see which one best explains this slope. So here now I can put in a skin thickness, and you can see the result is now not significant. We're not significantly explaining any of the variance in skin thickness with slope. And if you plot this, you'll know the data is it's not going to look particularly nice. It's just going to look all over the place. There we go. There's why we've got a few crazy outliers in here. Maybe somebody can go through and figure out what these outliers are doing. Um, these presumably should have been um, point two, I imagine, and this should be 0.65 or something like that. But go through and fix those up and have a look. If we look at fur density, again, we do have a significant effect now, and if we plot that, I can change this to fur density, and we can plot that. You can see there is a significant effect, but it's much weaker because right now our R squared value is 0.13. So we're only explaining about 13% of the variation, but we're significantly explaining 13% of the variation. So when it comes to picking between these three, you want to have an idea of which one's significant, which one's not significant, but also which one explains more of the variance. And so that's how you're going to decide which one to plot at the end. Okay, so I'm going to plot fur length, and hopefully you'll come to the same conclusion. And I want to plot it in a nice way, and I'm going to put some colors. And so what we're going to do now is we're going to use something called a package. And packages are these groups of functions that you can import into R. I'm going to import one called R color brewer. And if you run this line, it should install the package onto your computer, but you only have to do that once. Once you've installed it onto your computer, you don't have to install it again. I've already installed it onto my computer, so I can just run this library function now, and that will pull up all the functions inside this R color brewer and make them available to me to R to use those functions. The first function I like to call up is this display brewer all, and that's going to display all these different color palettes that are available through this package. And I really like some of these color palettes. And you can see there's some yellows, some oranges, or you can have these sets here. And they're just really nice colors that have all been put together. I'm going to use set 2 here because I like set 2. It's got some nice pastel colors. And I'm going to use this function BrewerPal. And BrewerPal wants to see, well, how many colors do I want and from what set? So I'm going to ask it for 5 colors from set 2. And you'll notice that it gives me those crazy color codes back, which R can understand, and turn that into some colors. Okay, so now I can plot my fur length, and now I can define the colors differently. So the way we're going to define the colors is a little bit tricky to think about. But here's my fur data, and remember my fur data is a list. We could also display that fur data as a factor. Oops. And if we do that, sorry, I should say as numeric. And if we do that, you can see it changes it all into numbers. So these are ones, these are twos, these are threes, fours, and fives. And so what we can then use is that index, because now all the calves, for example, are 1. You can see there's 3 calves here, and then there's a few more calves here, which are also 1s. When we put it in, when we try and call an index using these labels, R automatically figures out that I mean it to be numbers, and it's going to try and call that number from this group of colors. So remember, this is our colors, and so this is now going to create a vector of colors that are based on that fur number. So you can see here, all the calves are going to have the same colors. That's nice. And all the controls are going to have this other color. So I can now tell R to plot that data using the different colors, and we get something like this, which looks quite nice. Of course, we want to add a legend, and we can do that using this legend function. In this case, I have to tell what the legend is going to be plotting, and I want it to be plotting these 5 levels. So I'm going to use that levels function to get the levels out of this. Remember, this is a long data set here. I'm going to tell it what shape them to be and what color they want to be. In this case, we only have 5, remember, and so I can call up my 5 colors from that color palette. And we can plot it in this case in the bottom right hand corner. Now it's a little bit small there. I can make it a bit bigger, maybe make it 1.5. It goes bigger. If I try to make it too big, it starts to cover up my data. You can see I'm missing that green dot. That might not be such an issue. Um, if it is an issue, you can also try and move this around. So I could put it at the bottom, but if I put it at the bottom, it's just going to align it with the center bottom here. What I want is to add in this horizontal true, which is going to make all my labels here, instead of being stacked in a row, they're going to go along the bottom, and it would look something like that. And I could try and make that big too. So you can play around with that. Obviously, that's too big. That would be better, but now if I want to clear it, I have to replot the data and then put another label there. And you can see that's my way of adding a legend to the plot now too. Okay, so that looks good. That's a good start to our data set. But what happens if you don't have a color printer? What can you do then? Well, we can actually go back to our color palette, and you can see there's actually one called grays here. That's all different shades of gray. So we can call that one up. So I'm going to call that color palette here. And now I can plot it using the same commands, but now because coals is now grays, it's going to plot them as different shades of gray. And I can add in my legend again here in this bottom corner, make it a bit bigger so we can actually see it. Now, one thing you notice though is this calf, that first color of gray is really, really, really light gray, and you can barely make out the points. So what can we do about that? Well, we can actually change this type of circle, and rather than having just a circle, I could put a circle with an outline. And so that's this PCH. Remember, 20 is just a solid circle, but 21 is a circle with an outline. And we can define the color of that outline. In this case, I want the color of the outline to be black, but I want it to be filled with different colors. And so that's what this BG command is now, is going to fill the inside of that circle with my different colors of gray. So there we go. So now you can actually see those points that they turned out. That might be a bit too big. It's starting to look a bit funny. That's looking a bit better. And we can add in this legend. Remember, we have to change the type of symbol we're using here. Colors, if I run it like this, we're going to get those colors as being the outside circle. So we actually want color to be black. But now I have to define the inside color again. And the way we do that in R is I just Googled here, PCH21 in legend. And you can see I saw an example that I liked where they got the 2 different symbols. And I looked down in their legend and I could see that they have this point background function. So I could take that point background, which is what I want, and I can add that into my legend call. And now instead of red and blue, I want this to be those coals right here. And I only want 5, so I'm just going to call this coals thing here. And hopefully that works. And it does. So it's looking nice. Now we have a nice way to make a black and white plot as well. But we can go back to colors and make it look good. So I can put the outlines of those colors around. And we can get to that stage here, and we can run this legend line again. And now we have our different colors with a really nice looking circle around it. So everything's looking good. But what if we use different shapes as well as different colors, just for fun? So here we have to get a little bit more tricky. Remember how I said we can use as numeric a function and turn all our fur data into numbers? Well, we can actually put them into that PCH. So here you see I put as numeric into that PCH command. So when I plot it now, it's going to plot each one as a different shape. So here are all the controls. Here's one, here's another. And we could add in a legend into this, but I don't want to use, see here now it's using PCHs 1, 2, 3, 4, 5. And if you want a list of what PCHs are available, you can just go to Google and type PCH and R, and you can see it's like pretty much the first hit that's going to come up. Um, Here's 1, 2, 3, 4, 5. So those are the symbols that are coming up here. But what I really want to be using though are these filled in symbols here, 21, 22, 23, 24, and 25. So I want to start at 21. Well, that's easy to do. I can just add 20 to that as numeric. And if I did this as numeric plus 20, you can see it's just going to add 20 to all those. So now I can start using these shapes where the outline is going to be black and the inside color is going to be based on my color. And I'm going to have these nice different shapes for each of mine. When plotting the legend with these, it gets a little bit trickier again. Again, we have to define which shapes. And so now I've put PCH as 21 to 25. So it's given me a list. And the background is just going to be colors. And now we can have different shapes and colors in our plot. Finally, don't forget to plot your line. We can run that linear model to create this fit function, and then we can run this AB line on our fit to put a line in. We can play with a few parameters here. We can change the color of the line. We can change the width or thickness of the line. We can even change the type of line here, and you can see LTY equals 2 is for a dashed line. And if we go to Google, we can type in LTY in R, and if you just look here, you can see 2 is dashed, 3 is dotted, 4 is dot dashed, or we could just stick it as 1 for a solid line. So we can have a play around with the type of lines that we want. We can make them thicker if we want to make them really stand out. Oh God, that's ugly. If we want to just a solid line, we can go about doing that. And so we can make our plots look a little bit nicer. And remember, once I've plotted something on there, if I want to get rid of it, I have to replot it one more time. And that's our little solid line there. Okay, so that's a little bit of an intro into how to make fun plots in R.